Could you imagine that there's a law that states that you must take your car to every place you visit, like countries and cities, away from your home, all because you might require a car when you're moving or traveling locally in the new city you're visiting? And chances are that in this your trip, you might get a lift from a friend or a family member that you don't even need your car most of the time. So, this is exactly what happens when we write software programs or web programs that are tightly coupled or dependent on the parent classes. So, if we have a parent class that has so many methods, and some of the dependent child classes are forced to implement these methods even when they don't have any use of them, then this is in violation of the single interface segregation principles. So, interface segregation principle states that clients should not be forced to depend on methods that they don't have any use of, according to Robert C. Martin, who is also known as Uncle Bob. So, interface segregation principle is similar to the single responsibility principles. So, if the base class, which is the parent class, has methods, multiple methods, and there are child classes who depend on them who have need for maybe one or two methods out of all the methods in the parent class, the child classes should not be forced to implement these other methods that they don't have any use of. So, how do we solve this problem? This problem is solved using the interface segregation principle by creating interface classes which are going to implement only the methods required by the child classes they are servicing. So, looking back at our car illustration, just the car rental companies and transport companies serve as our interface for our car we have at home when we are away from home, right? So when you're on a trip, you cannot only call the rental services when you need a car. But when you don't, so you just move around any way you find fit. So look to illustrate the interface segregation principles in Python, let's make a simple computer program or computer device with different classes like printers and scanners. So to first of all, we'll write a program that violates the interface segregation principles and also refactor the program to show you how the good use of interface segregation principle is done in your program, so that this will help you in your coding. So let's go to my IDE now and code that out. So looking at the program illustrated here, the device class, which has an abstracted method of the print document and the scan document, is actually forcing the printer and the scanner classes to implement both methods, which is not supposed to be so. So like here, even though the printer can scan in this our program, but because it's a direct child class of the parent class, which is the device class, it is forced to implement all the methods that has been introduced by the parent class. So, and also the scanner class, even though it cannot print, it is also forced to implement the print document method because it's a direct child class of the parent class as well. So, but in this program, because it's a simple program, it works perfectly. There's nothing, it doesn't look like anything is wrong with this program, but moving forward, when we are trying to scale our program and build more large programs, this is going to be seriously a problem, and it's kind of tightly coupled and it's not flexible for scalability. So now we're going to refactor this program to actually show you how the interface segregation principle should be implemented in the real sense of it. So right now I'm going to create another program, or yes, I can create another Python file to illustrate this. So I will call this let me call this computers, because they are all computers. So in this computer class that I've created, I'm going to simply create a printer class, which is going to take care of our printing activities. A printer device, and this is also going to take all our printing activities. So now, going back, we're still going to abstract this because Python makes use of abstracted methods. So we're going to define these methods, which is just print document, under this class. And it's going to have document parameter. So we're going to just put pass, because this is not where we're going to implement this method. And we're going to create another class, which is the scanner device. So this is going to take care of all our scanning jobs. Okay. So it's also abstracted. So this is going to be pass. So because we're not implementing this, so we're going to create the printer class, which is going to inherit from the printer device. Inherit the printer device, which is printer device here. So here we're going to implement this method, the print document method, and in this print document method we'll just output a print to print something on our console. So once we do that, we're going to say printing document, and we're going to assign this to the document element. So yeah, so with that, now we'll also go, let's also create the scanner class as well. And this scanner class can only implement the scanner device here. So, and we're going to define the method scan document, and we're going to output this on our console, and we're going to output a simple message which says scanning document. Okay, and the scanner parameter. So with this now, you can see that each printer and scanner only implement the interface that is relevant to its functionality. So this adheres to the interface segregation principle, because the printer class only inherits from the printer device, and the scanner class only inherits from the scanner device, which only has a method that only scans a document. So let's see, you put this in usage and see that it also outputs the same result. But for bigger programs, which, let's start with the printer and create a printer and assign that to the printer. So we'll just call printer dot print document. You see that? So let's say we're printing my document, right? So if we do the same for the scanner class as well, we'll say scanner and assign that to the scanner class. So once we assign that, we can output a simple message. Oh, sorry, we can call scanner dot scan document. You see, so each one of them is dependent on the parent class. It doesn't have to start implementing what it doesn't have any use of. So, and here we're going to also output my documents, because you can scan documents and you can print documents, but you need to know how to call the right function. So once we run this, I think there's an error. Oh, sorry, there's a typo error here. So let's run that again. ABC is not defined. Okay, so you have to define ABC. So import ABC as ABC abstracted method. So our program should be fine now. So you see, printing document, my document, scanning document, my document. So you can continue modifying this any way you want it. In case you have to print some documents in color and black and white, you can also include that method in this printer device. You can select colored printer and black and white printer. So this is why interface segregation principle is important, and is also similar to the single responsibility principle, so that each class or interface can only do one thing and focus on that one thing. So but that is not restrictive though, because you can print a colored and a black and white document at the same time. So this is what this principle is all about, and I hope this scratched it for you and it makes this concept clearer for you. So if you are new to this channel, I will urge you to subscribe for more videos explaining software design concept to you and making it simple and making you a better programmer. So I hope to see you on the next one. So if you have not seen the other videos we've done on the other parts of the same solid principles, you can see them here in any part of the screen where you can watch the other videos. So I hope to see you on the next one.